Hello students, my name is Sushan Garg and I'm back with another question of JEE Advanced, which is related to the chapter of thermodynamics and has been asked in the JEE examination in advanced paper in 2022. This question can be said as a mixture of fluid mechanics and thermodynamics, because what happens, we are using here continuity equation of fluid mechanics and adiabatic relations of thermodynamics. Both are being used to find out the answer here. This question is of single choice correct answer. The is or are, do not get confused by the which of the following statement is are correct, but only one answer here is correct. Single option correct question is this. So let us begin with the solution of this question. It has been given that ideal gas of density 0.2 enters the chimney. So density of gas which is present here having density 0.2 at a height h enters the chimney at the height h at the rate of 0.8 kg per second. The mass flow rate of this gas is being given. The mass flow rate here is 0.8 kg per second from its lower end and escapes through the upper end. So upper end is this, and here the mass flow rate is also according to the continuity equation. The mass flow rate here will also be 0.8 kg per second. The cross sectional area A1 is given 0.1 and the upper end A2 is given. The pressure and temperature of the gas at the lower end here, let us say the pressure is 600 Pascal, the temperature is 300 Kelvin, and while its temperature at the upper end is 150 Kelvin. Here pressure is not given, but the temperature is given as 150 Kelvin. He pressure do not know we, but आपका temperature is given 150 Kelvin. Here density is not given. Density is not given. So next part is that the chimney is heat insulated. No heat is going inside, or no heat is coming from inside to outside and outside to inside. No heat exchange is there. The process is having adiabatic expansion technique. So G की value दी है, the value of G is given as 10 meter per second square. The ratio of specific heats gamma is given as 2. Ignore atmospheric pressure. Okay. So here the atmospheric pressure, here the atmospheric pressure, in the both the cases are being ignored. So 4 options is given. The first option says that the pressure of the gas at the upper end of the chimney is 300 Pascal. Let us see whether the pressure of the gas at the end of the chimney, upper end of the chimney is 300 Pascal. So whether this value is 300 Pascal, we have to check. So to calculate P2, we can use the pressure temperature relation of adiabatic process, that T gamma P1 minus gamma is a constant. So this will give us T1 P1 1 minus gamma equal to T2 gamma P2 1 minus gamma. The value of T1 is 150, gamma value is 2, P1 value is 600, we will get 1 minus 2, T2 value is 150, T1 value is 300, T2 value is 150, to P2 we have to calculate 1 minus gamma means 1 minus 2, 300 square, this will give us 600 inverse, 150 square, P2 inverse. We will arrange it. P2 inverse will be equal to 300 square into 600 inverse upon 150 square. This will give us P2 inverse is equal to 4 into 600 inverse. So 4 into 600 inverse will give us 150 inverse. So P2 will be equal to 150 Pascal. So if we check the option, the first option is not correct. The pressure of the gas at the upper end of the chimney is 300 Pascal, not is given as 300 Pascal, but it comes out to be 150 Pascal. So this is not correct. Now, but just remember the pressure which is coming out to be 150 Pascal, the value 150 Pascal, just remember this. It can be used in the next calculation. The next calculation we have to do is of the velocity of the gas at the lower end. We have to find the velocity at the lower end and the upper end. Now, we know the mass flow rate at the lower end and the upper end both are equal, and its value is given is 0.8. So, for the lower end, mass flow rate is given as 0.8, and it can be, mass flow rate formula is density at the lower end, area of the lower end, and velocity at the lower end. So 0.8, lower end density is 0.2, area is 0.1, and velocity is v1. So 0.8 by 0.2 will give us 4, and 4 by 0.1 will give us 40 is the velocity at the lower end. Now let us check the apparent velocity. Mass flow rate at the upper end will be also 0.8, because mass flow rate according to the continuity equation will not change in the lower end, and at the upper end no extra mass has been added. So for the upper end, density at the upper end, area at the upper end, velocity at the upper end. In this mathematical equation, we know A2, we don't know V2 and rho 2. We can calculate rho 2 with one of the unique relations of adiabatic process, that P by rho to the power gamma is a constant, which will give us P1 by rho 1 gamma equal to P2 by rho 2 gamma. So P1 value is 600, rho 1 value is 0.2 power 2, P2 value is 150, rho 2 value is, we have to calculate square. So it can be arranged as rho 2 square 150 by 600 into 0.2 ka square. 150 by 600 1 by 4, 0.2 ka square 0.04, 0.2 ka square 0.04. Whether we are doing any calculation mistakes here? Yes, one small. 0.2 will come out at the numerator. This will give us 0.04, which gives us 0.01. Rho 2 square is 0.01. So rho 2 will be 0.1 if we take the root. So rho 2 has came out. Now let us check the fourth option. The density of gas at the upper end is 0.05. This option is also wrong. Now we want to calculate the velocity at the upper end. So just remember the density at the upper end is 0.1. So using this in our previous equation, that is rho 2 A2 V2, putting the value of rho 2 0.1, A2 0.4, given V2 we have to calculate 0.8 by 0.4, 2 by 0.1, we will get 20. Upper end velocity is 20, which is given the B option. So B option is correct. So option correct we got, but there is one part also which you have to calculate as a homework. That part is the height of the chimney. Try to calculate the height of the chimney using the concept of fluid mechanics or any concept of thermodynamics. Try to solve it on your own. Answer whatever the answer you are getting, please put it on the comment box. I'll tell you whether it is correct or not. Or if you have any query related to this question or any other question, you can put it in comment box. I'll reply it as soon as possible. Just try to practice more and more questions of advanced examination which has been asked previously to boost your preparation, and wait for the next video. In the next video, we will give you the advanced question of heat transfer topic and try to solve that question, and after that we'll give you oscillation in waves. So wait for the next video and study hard. Goodbye, good night. All the best for the upcoming examinations. Thank you, students.